Hi everyone, this is a look at molarity, molar concentration. This is the standard way of expressing concentration in chemistry. We've already seen it. It's an expression in moles per liter. This is called molar concentration or even molarity. They're all used interchangeably, synonymously. So if we had an example of 3.00 moles per liter, we might even just say that's 3.00 molar. That's the molar concentration. It's the solution's molarity. All those three fit together. Molarity, molar concentration, moles per liter, they're all the same thing. We have this formula, C equals N over V, where C is the concentration in moles per liter. That's the molar concentration. N is moles, and V is volume in liters. Lots of the time questions will give us milliliters. We must have liters for this formula to work. We're going to have one-step problems sometimes to solve for C, solve for V, or possibly even solve for the moles. But watch out for those times where we have two-step problems where we have a mass involved. As soon as there's a mass and a concentration together, as long as it's about molar concentration, we're going to have two steps. There's three possibilities. If we're asked to solve for the mass, we have to do C times V first to find the moles and then carry our answer forward and multiply by the molar mass. On the other hand, if we have the mass, we might be asked to solve for the concentration or to solve for the volume. Depends what they give to us and what we're being asked to do. However, in both cases, we'll do mass over molar mass first. To solve for the concentration, we'll take our answer and divide by the volume. To solve for the volume, we'll take our answer and divide by the concentration. It's really important to highlight at this point that this is not stoichiometry. We do not have a mole ratio. We do not have a balanced equation. None of that. Just use the one formula or do two steps. Here's two examples. What is the molar concentration when 156 grams of ammonia are dissolved to produce 2.00 liters of solution? What is the molar concentration? It's saying, what's the molarity? What's the molarity? Maybe we want to throw some labels in. It's been a while since we saw these kinds of problems. What is the molar concentration? This is saying, can you find C? What's the molar concentration? 156 grams, that's the mass. The idea that it's ammonia matters. And we have 2.00 liters of solution. There's the volume. So we have the mass and the volume. We're looking for the concentration. Here, we don't have the moles. So this is a two-step problem. Again, as soon as mass is involved with molarity, we're going to have two steps. So look at what we have here. We're going to do mass over molar mass to find the moles. And then we're going to divide by the volume to give us the concentration, these two steps. The moles is 156 grams over the molar mass of ammonia. Ammonia, you could find in the data booklet, it's NH3. That's 14.01 for the nitrogen, and 3 hydrogens at 1.01 each. The molar mass is 17.04 grams per mole. I do that operation, 156 divided by 17.04, gives me 9.154929577 moles. I'm not going to round off my answer at this point. I'm going to carry it forward. It's still just sitting on my calculator screen. And the concentration is going to be that answer, these moles, this answer divided by the volume, 2.00 liters. This answer is already sitting on my screen, 9.15, etc. So I just divide by 2. We end up with 4.5774644789. which we need to round off to 3 significant digits, which equals 4.58. 4.58, it rounds up. And this is the molar concentration, 4.58 moles per liter. First, we did mass over molar mass to find the moles. We carried our answer forward, divided by the volume, and paid attention to our significant digits and units. One more example. What volume of 0.700 mole per liter sodium phosphate can be prepared from 126 grams of solute? What volume? Looking for the volume, question mark. 0.700 moles per liter, that's the concentration. Sodium phosphate is going to be significant, and here 126 grams is the mass. Maybe you yourself don't need some labels, however, it can help you to understand what's being asked and what's being given to you. Again, notice neither of these questions describe a chemical reaction. We're not balancing an equation or some of the things that we've done in the past. Again, we're starting with the mass. So we have a mass over molar mass. The moles is 126 grams over the molar mass of Na3PO4. That's 3 sodiums at 22.99 each, and a phosphorus is 30.97, and 4 oxygens is 64. It's 163.94 grams per mole. I do that operation, we get 0.7685738868. That's the moles. That number's just sitting on my calculator. I'm not rounding it or doing anything at this point. And then the volume is this answer over the concentration. What we did was we did mass over molar mass. We are going to solve for the volume, so we're taking our answer, putting it over the concentration. That answer is already there on my screen, so now I'm just dividing by 0.7. It's 1.0979626669, which I need to round off to 3 significant digits, 0.700 and 126, 3 significant digits. Here I'm actually rounding up to 1.10. And this was the volume that we found, liters. The possibility exists when we're doing molar concentration just to have a one-step problem. Don't fool yourself. That is a thing that can still happen. We might psych ourselves out and think, well, that's too easy. One-step problems do still exist. Please remember that molarity, molar concentration, we saw over here, molar concentration, and moles per liter are all the same thing. We have 3 different scenarios that are going to give us 2-step problems. We just did 2 of them. Both of them started with mass over molar mass, and then we solved for the concentration the first time and the volume in the second question. The possibility does exist for this other 2-step problem where we do C times V first to solve for the mass. As always, watch those significant digits, watch that rounding, watch those units, and I hope that helps.